we'll be discussing highest common factor in this video. Okay, this is video number 19. Let us continue. Let's look at the outline of these videos here. Okay, we'll discuss HCF. What is HCF is highest common factor. Okay, we will discuss highest common factor, what it is and where it is used. Then after that we'll do compute there, and first thing we'll do using factors. Okay, then we'll discuss using divisions. Then we'll use it by addition and by subtraction sutra. Okay, let's continue here. What's HCF good for? Okay, why do we need to know about HCF and to compute HCF? Okay, let's continue here. Why do we need HCF? Okay. Answer: we use it in everyday life. Okay, so we use it in everyday life, and it's so you need that. Okay, here's some examples. Say a milkman delivers milk, and his customers buy milk in 2 liters, 3 liters, and 5 liters quantity. Okay, so what's the largest one measure? Okay, he only wants to use one measure he needs to carry. He doesn't want to carry more than one. He wants to carry only one. Okay, and he also wants to carry the largest one. Okay, let's continue. Example: a housewife wishes to decorate 16 feet by 24-foot room with square pieces of different color carpet for a quilt-like look. Okay, what's the largest size of the carpet squares she can use? Okay, she must use squares here. Okay? Okay, she can use. Okay, let's continue here. Linda wishes to carpet, another example, 12 feet by 12 feet. This is square room. However, carpet comes in 9 feet width. Okay, and she buys 16 feet of the roll, and she cuts the carpet in 2 pieces and perfectly carpets the room. How did she do it? Okay, she uses HCF in this task. Okay, let's continue from here. Okay, let's look at what is HCF. Okay, let's continue. It's a What's HCF? It's a highest common factor. H for highest, C for common, and F for the factor. Let's continue here. Note that it's also known by greatest common measure. The book Figuring uses this term greatest common measure, and also by greatest common factor. Okay, greatest instead of highest. These terms are equivalent. Greatest common factor. Let's continue here. So first of all, let's look at what it is. First is a factor. Second thing, it's a factor here, and factor here is called measure here. Okay, what's a factor? Factor is a divisor which divides a number evenly. Evenly means remainder is a 0. Okay, we studied these in a video on divisibility by remainder. Remainder is 0, and we use divisibility by remainder. We use that property. The sutra used here are proportionality and divisibility by remainders. Okay, let us continue. Common factor. The factor is common to all the numbers in the question. That means all the numbers are proportional to that factor. Okay, and highest common factor is, we are interested in one factor which is highest or largest of all the common factors. We're looking for a one factor which is highest or largest of all the common factors. Let's continue here. We will often use divide and conquer to find multiple common factors. Okay, and HCF is a product of all these factors. And how do we use that multiple common factors and multiply them out? You please continue to watch the videos, and that would clarify. If there is any issue here, we would clarify that during the subsequent slides. Okay, let us continue from here. continue here. And question now, have we used HCF before? Okay. Have we used HCF before? Okay. Answer yes and no. Okay. Let's explore what a yes means. In reducing the fraction 57 by 95 to the lowest terms, we notice that 57 is divisible by 3. 5 plus 7 is 12. 12 plus 1 plus 2 is 3. It's a digit sum is a multiple of 3. And 95 is, as ends in 5, is divisible by 5. Okay? Then we say that because of this property here, 57 divided by 95 is 3 times 19 divided by 5 times 19. Now we have a 19 as a common factor. Okay? So we divide both the numerator and the denominator by the common factor 19, and I get 3 divided by 5. So 19 is a common factor and is also a highest common factor. So we have used that HCF in this problem. We are trying to reduce a fraction 57 divided by 95 to the lowest terms. Okay, let's continue here. Let's look at it no example here. In reducing 777 by 21, we notice that both the numerator and denominators are divisible by 7. So both they are all 7, so divisible by 7, and 21 is numerator is 7 times 1, 1, 1, and denominator is 7 times 3. Let's continue here. Now it's a we have identified one factor 7. Okay, and so we represent 777 divided by 21 by its equivalent form, which is 7 times 111 divided by 7 times 3. Now we see 7 is a common factor. Okay, and it's a common factor, so we'll divide both the numerator and the denominator by this common factor. So that gives me 111 divided by 3. Let's continue here. Do you see that both 111 and 3 are divisible by 3? It's a digit sum is 3. Its digit sum is 3. A digit sum is 3 means numbers are divisible by 3. Okay, that means so we already have 777 divided by 21, which is equal to 111 times 3. Let's now we'll represent the gain in smaller numbers. It's a 3 is a factor, so it's 3 times 37, and 3 is a factor of the denominator, that's a 3 times 1. So we'll divide both the numerator and denominator by the common factor 3, and that gives me 37 divided by 1. 37 in numerator and 1 in a denominator, and which is 37. Okay, let's continue here. Continue here. We already have done that 777 divided by 21 is 37. Okay, let's continue here. Now here we use two factors, 7 and 3. We divided by 7 to get in a 111 divided by 3. Then we divide both the numerator and denominator by 3 to get in 37. So we have two factors, 7 here and a 3 on the second step. And both are common factors. Okay. However, we divided both numerator and denominator first by 7 and then by 3. In fact, we divided both by 7 times 3 equal to 21. Okay, 21 is highest common factors, and 7 and 3 are common factors. So we did use highest common factor, but we did not do that in one step. Okay, let's continue here. 21 is HCF of 77, both of 77 and 21. Okay, so we divided by both numerator and denominator by 21 because that is HCF of 777 and 21. Let us continue from here. Next section now. Okay. In next section we will talk about computing HCF and we will use using factors. Okay, let's continue here. and after that we'll use it using divisions, okay, and after that we'll do using by addition and by subtraction. Okay? Let us compute HCF using factors. Okay, and what are we looking for here? Let's question is what are we looking for here? Answer is we are looking for a highest common factor, and we will in this section we'll use it divide and conquer, okay, method. Okay, so question is what is HCF anyway? HCF is it's a product of all common factors. Okay, it's a highest common factors, and when we divide and conquer and get any factors that are common factors in pieces one at a time using divide and conquer, so we in the end we would have a product of all the common factors. Okay, so let's say what's the intuitive method? We have to find factors. What's the intuitive method to find HCF? It is find factors, identify common factors, multiply all common factors. Okay, so we have to find factors and then identify. So factors is to find factors of first term and number, second number, and so on, and then identify common factor of all the numbers involved, and in the end multiply all the common factors found so far. Okay, let's continue here. Note literature suggests using prime factors. Okay, and we'll use shortcut here. We'll just say we'll find factors first and then convert these to prime factors if desired. Just in case your teacher in school say use the prime factors, you can find factors first and then you can say, okay, we know everything we need to know. We're going to prime HCF, and here are the factors, and we'll convert those into prime factors. Okay, let's continue here. And going through the exercise, finding a HCF and then converting to prime factors will also give you a total enrichment. So we use shortcuts and then we come back to the textbook solution. Let's example here. And this example I'm getting from some online power presentation, and there might be some other examples from the same presentation in this book, in this video here. Let's continue here. What's HCF of 72 and 90? Okay? And that discusses two example by factors and by a list. Okay, let's continue here. Let's say what are these both number even? Okay, so we have to decide are the number by divisible by 2, 3, 4, and there's 5, 9, 8, 9, 11, 13 extra. So they are divisible by 2. Okay, so we'll just see what happens. 2 is, what does that mean? That means 2 is a common factor and 2 is a prime factor also. Let's continue here. That means 72 is equal to 2 times 36 and 2 times 45. Let's continue here. Are 36 and 45 both even? No, they're not both even. No. So that means 36 and 45 do not have another common factor of 2. Okay, let's continue here. Next question. Are both 36 and 45 divisible by 3 or by 9? They are. Okay, because 3 plus 6 is 9, that's digit sum. 4 plus 5 is 9, and that's a digit sum. Digit sum is 9. That means both of these numbers are divisible by 9 and also by 3. Let's continue. Digit sum of both number is 9. Okay, we just did say, and then both are divisible by both by 3 and by 9. So we already have decided so far. Okay, and that means 72, we would extract our factor of 9 from here. That's 2 times 9 times 4, and from 45 it's a 9 times 5. 2 times 90 is 2 times 9 times 5, and 72 is 2 times 9 times 4, and 90 is 2 times 9 times 5. Let's continue from here. Are both 4 and 5 divisible by a common factor? Not 1, other than 1. A factor, a common number other than 1. Let's continue here. Both are divisible only by 1. Okay, so HCF is 2 times 9. This is common here. 2 and 9, 2 and 9, 18. Okay, let's continue here. So we know we were here. What is the HCF of 72 and 90? That's the problem here. And the numbers are, so we came up to here on the previous slide. Then we say we had 18 was the HCF from 2 times 9. These are two common factors, and 2 is a 2, and of this 4 is 2 times 2. This 9 is 3 times 3. So these are my now prime factors. And in the second term, it's a 2, and then a 9 is 3 times 3 and a 5. Okay? So these, if they're looking for common prime factors, so these 2 and a 3 and a 3, these are the common, this last 2 3 3 and 2 times 3 times 3. Okay, and that means that's it. In the first number, 2 appears 3 times and 3 appears twice. In second number, 2 appears 1, 3 appears twice, and 5 appears 1. 3 appears twice in second number, and also 3 appears twice in the first number. So that is one of the common factors. And 2 appears once here, and 2 appears 3 times here. The 2 is another common factor. Okay, let's continue here. Common factor is 2 times 1, 2 power 1, and 3 times power 2, okay, which is 2 times and 9. And the HCF is 2 times 9, which is 18. Okay, we already knew that, but now we have used the prime factors in case you desire. Okay, let us continue from here. Okay, now we'll use a list method, which is proportionality. And PowerPoint presentation discusses also a list method. According to this method, so we get 72 is 2 times 36, okay, which is also equal to 3 times 24, is equal to 4 times 18, and also equals to 6 times 12. Okay, let's continue. And 8 times 9. Okay, and 90 is equal to 2 times 45, 5 times 18, 6 times 15, 9 times 10. Okay, and 18 is the common factor here. 18 here and 18 here, and we use the highest factors here. So 18 is the common here and is highest common factor. Okay, let's continue from here. Common factor is 18, and which is also highest. HCF is 18. Continue and see. Look at HCF of 225, 675, and 950. Okay, let's complete. Example is HCF of 225, 675, and 950. Let's continue here. Do you notice any common factor here? Are all these numbers divisible by 2, 3, 5, 6, 8, 9, 10, and 11? Okay. They're not even, so they're not divisible by 2. Okay, this one is divisible by 3, but this one is divisible by 3. Okay, 2 plus 2 plus 5 is 9, and this is 6 plus 7 plus 5 is 18, and this one is not divisible by 3, but they are divisible by 5. Okay, so 5 here, and a 0 at the end. Okay, let's continue here. All the numbers are divisible by 5. Question: are these numbers divisible again by 5? Answer: yes. In fact, we noticed that the numbers end in 25, which is 1 times 25, 75, which is right here, which is equal to 3 times 25, and 50. 50 is this number here, which is equal to 2 times 25. Let us continue from here. So 25 is the common factor. Okay, then my numbers are, I replace 25 by the prime factors, 5 times 5 times 9. Okay, and the second number is 5 times 5 times 27. 675 has a 27 factor of 25. 675 is 25 times 27. Okay, similar. 950 is 25 times 38. Okay, let's continue here. Do you notice any other common factor from here? Okay, so 9 is divisible by 3 and 27 is divisible by 3. 9 is divisible by 9 and 27 is divisible by 9. But 38 is not divisible by either 3 or by 9. It's divisible by 2 and by 19. Let's continue from here. Are 9, 27 divisible by any of these numbers? 2, 3, 9, 11, etc. 9 and 27 are divisible by 9. Give this first number 9 here and 27. They are divisible by 9. Its digit sum is 9 and its digit sum is 9. Okay. And 38 is even number and it's by 2 and 19. Okay. So not a common factor for all of the numbers. Let's continue here. Let us continue. Okay, so we have gone so far. Okay. So HCF is finally 25 because there are no other common factor. These are two common factor 5 and 5. Actually we started with 25 and then we replace them by the prime factors. Let's continue here. So 225 is like 3 times 3 times times 5 times 5 times 5. 3 squared and 5 squared times. Okay, 675 is 3 times 225 and which is equal to 3 3 times and 5 twice. Okay, 3 power 3 and 5 power 2. Let's continue here. 950 is 2 times 475. Okay, which is 2 times 25 times 90. Okay, 5 times 5. Okay, which is 2 once, 5 twice, and 19 once. Okay, let's continue here. And common factor is have it 5 twice here and 5 twice here and 5 twice here. Nothing else is common here. 3 twice in this first number, 3 times the first number, and it doesn't show up in the third number. Okay. Take this example here, HCF of 30 and 120. Okay, let's see what's we're going to question. A teacher has 120 crayons and 30 papers. Okay. What's the maximum size of a class to allow the teacher to distribute crayons and papers evenly? Okay. So there are 120 crayons and 30 papers. We're trying to find a largest size of the class such that teacher can distribute crayons and paper evenly. Okay, let's continue here. The two numbers are 120 and 30. We're looking for maximum highest, which is a HCF. Okay, let's continue here. Do you notice an common factor? Okay, do you see any number, one number multiple of the other? 120 is a multiple of 30. Okay. Yes, and that number is 30. Okay. We use that something similar, the same property, we use that in adding fractions or subtracting fractions when one denominator was multiple of the other. Okay. So we know that one number is multiple of the other. We have used that before. Okay, let's continue here. And then so this number is 30. So we're doing factors here. Okay? So 30 is our highest common factor. Let's go do the list method now. Using list method, we have 1 times 30 is 30 and 120 is 4 times 30 and 30 is a common to both of those and 30 is a common factor and also the highest common factor. Let us continue from here. HCF is 30. Okay. Let us continue. Okay, let's look up, uh, use some examples of the number we have already run into in one form or the other, and we run into 142857 and 999 before. Let us see if we can find a common factor. Okay, highest common factor in fact. What's the HCF of 142857 and 999? So we'll use all the shortcuts we can think of. Okay. Do we notice anything special about the first number? First number is 142857. Anything special about this number? Let's continue here. The two parts of 142 and 857, these two parts are 142 and 857. If I add these two, I get 142 plus 857, which is 999. So this is a sequence of 9. When I added up this number 142 and add 857, I get a 9, 9 and 9, 3 nines, with a sequence of 9s. Okay, that means this number is a multiple of 999, and we obtained this number by multiplying 143 by 999. Okay, how do we know that? And refer the video multiplication by sequence of nines. We used that topic discussed twice, one in using all from 9 and also in section by completion. Okay, so refer the video on multiplication by sequence of nines. Okay, so 142857 is 147 times 999. From this property, 142 plus 857 is 999. These two parts, 142 and 857, are nines complements of each other. Okay, when two parts are of same size and nines complement of each other, then this number comes from multiplication by sequence of nines, and that is 143 times 999. So at least we know that first number is 143 times 999. Okay, let's look at second number now. Do you see anything special about this number? 999, 999. Let us continue. And the two parts are equal. 999 and 999. The two parts are equal. Does that tell you anything? How would someone obtain the two equal parts in a number? Let's continue. Here is one of the methods we will explore here. Notice that when we multiply 1 by 3, I got two parts equal 3 and a 3. Okay, so there are two ones and no 0 here. Okay, then we get two ones guarding a single 0. Here, two ones guarding a 0 knots. Here's two ones guarding a single knot, and here is a two ones guarding a two knots. Okay, let's continue here. So, and 101 times 67 is 67, 67. Two numbers are equal. 67 first part of the number and 67 is second part of the number. Two parts of the number are equal. Two parts of the number are equal here, and we are going to try 1001 times 253, and two parts are 253 and 253, and they both are equal, just like these two numbers. Does that tell you anything about one of the factors of this number? 999, 999. Okay, let's continue here. And that means that 9999, 999 is equal to 1001 times 999. Just like that. 3 digits number here and 3 digits duplicated. 253 and 253. Here 3 digits, 6 digit numbers here, and they duplicate 3 digits, and we will obtain that by 1001 times 999. Okay, and that is continue from here. So, and the two numbers are 143. Now we have this number is, second number is 1001 times 999. The first number is 143 times 999. The two numbers are 143 times 999 and 1001 times 999. Let's continue. So let's continue with the same example here. And we already know that the two numbers are 143 times 999 and 1001 times 999. That is okay. Do see any common factors in here? So I know we know 999 and 999 are common factors. So let's look up the other factor now, 143 and 1001. Okay. Continue here. Both are divisible by 11. Okay. Can you think of then why 3 plus 1 is 4, and which is the middle number. Okay, here 1 plus 0 is 1, and the other two digits add up to 1 also. Okay, so it's just like here 2 digits add 3, and plus 1 is 4, and middle is 4. Here same thing. Here alternate digits, 1 plus 0 is 1, and 0 plus 1 is 1, so they add up to both. Sum of two alternate digits is equal, so both are divisible by 11, and we discussed that in a video. Divisible by remainders, and method used was digit difference method. Okay, let's continue here. So the numbers are 11 times 13 times 999. So this is 11 times 13 we divide by 11, and second number is when we divide 1001 by 11, I get 91 here. 11 times 91 times 999. Okay, if we need some time to ensure that 1001 is 11 times 91, okay, you just think about it and work it out. Okay, let's continue. So now 13 and 91, we have 11 is common factor, 999 is a common factor, and 999 is a common factor, and we have 13 here and no 13 here, but 91 is a multiple of 13. Do 13 and 91 have a common factor? Both are divisible of 13. This number is 13 times 1, and this number is 13 times 7. Okay, so we have a 11. First number is 11 times 13 times 999. Second number is 11 times 7 times 13 times 999. You see any common factors here? 11 is a common factor, 13 is a common factor, and 999 is a common factor. 11 is here, 13 is also here, 999 is also here. Okay. Okay. So what's HCF of 142857? That's what we're talking about. So far we discussed that the numbers are 11 times 13 times 999 and 11 times 7 times 13 times 999. Okay. So now how do we determine? Can you determine HCF now? We know all the common factors, which are 11, 13, and 999. Okay. Then HCF is 11 times 13 times 999. Okay, let's continue here, which is 143 times 999, and which is 142857. That's the first number we had. Let's continue here. So HCF is 142857, which is also the first number. Okay. Now we already know HCF, we already computed it, but we did not use the prime factor. Okay, let's continue. So now what's HCF here of 142857, and we already know that's what it was. Okay, so let's go do the prime factors here now. Okay, now so 11 is prime and 13 is prime. Okay, 999 is not a prime factor, so let's continue that and split that into prime factor. So first of all, I know that 9 is a factor of 999, and so it's 9 times 111, and 9 times 111. Okay. And 9 is not a prime factor, but 9 is equal to 3 times 3. Okay, let's continue here. So there's 3 times 3 here, and 1, okay, and 3 times 3 here instead of 9. Let's continue. Now look at 111. Is that divisible by any number? How about 2? No. How about 3? Yes, so 1 plus 1 plus 1 is 3, and 1 plus 1 plus 1 is 3, and digit sum is 3, and so it's divisible by 3. Let's continue here. So we have 11 times 13 times 3 times 3 times 3 times 37, and 11 times 7 times 3 times 3 times 3 times 37. Let's continue here. So common prime factors are 11, 13, 3, and 3. This 3 twice here and 3 once here, and 37. 37 here, 37 here. And that's also same number. When you multiply them all out, I got 142857. Okay. So let us continue. So we were able to do a shortcut here, and also we can do it through prime factor. Let's continue. Let's do HCF of 27 and 999. Okay. What's HCF of 27 and 999? Okay. Let's see the first thing we look at, are these any of these numbers divisible by 2, 3, 5, 7, 9, and 11. Okay. Let's continue. But 9 is a common factor here, 9 is common factor here. Okay. So we have a 9 times 3 first number, and second number is 9 times 1, 1, 1. Okay, let's continue here. So we have a 3 and 9 we just got. We have 3 and 1, 1, 1, the factors to worry about. Do they have any, these two have a common factor? Any common factor? Digit sum of both is 3, and they are divisible by 3. So we have a first number is 9 times 3, and second number is 9 times 3 times 37. Okay, let's continue. Do you see any, all common factors now? You better see, because 37 is a prime number, and it's not in the first number. Let's continue here. These are 9 and 3. So 9 and 3 is common here. 9 and 3 are common factors here. 9 and 3 are factors here. 9 and 3 are factors here. They both are common. So 9 and 3 is common factor of the two. So that is, what's the HCF now? We have one factor 9 and one factor 3. So 9 factor HCF is 9 times 3 is equal to 27. So we did not use a prime factor, we used a 9 instead, and 9 is equal to 3 times 3. So if you need a prime factor, well, let's find out. Another example. A farmer wishes to plant 50 apple trees and 30 peach trees in rows, okay, such that all rows have equal length. Each row has same number of apple trees. And what's the maximum number of rows? Okay, that's the question. 50 apple trees and 30 peach trees. Okay, all rows are equal length, and each row has the same number of apple trees. And what's the maximum number of rows? Okay, let's continue. What's the HCF of 50 and 30? That's where the question is here. Okay, we're looking for maximum number of rows that comes from HCF of 50 and 30. Okay. Do you see any common factor here? Okay. Is it 5 a common factor? How about 2? They both are. Okay, let's continue. 5 is a common factor, and so is 2. Okay. So it is 10. Okay. Common factor is 10. Let's continue. The farmer will have 10 rows, and each row will have 5 apple trees and 3 peach trees. So we'll have HCF is 10. We have 10 rows, and there were 80 trees here. 50 plus 30. So each row would have 8 trees, 5 apple trees, and 30 peach trees. Okay, let us continue. Okay. So let's look up discuss this thing. Okay, all those are equivalent. That's the problem here. Okay, we know that from the previous slide. So apple trees, and these are ratios here. So we use in proportionality and ratios, which 50 to 30. Okay, and the reduced form is 5 to 3. So ratio of apple trees is 5, and of the peach tree is 3. The farmer needs to plant a minimum of 5 apple trees. See, 5 and 3 cannot be divided further evenly, so, and 3 peach tree. Then each in each row. So that's each row have to have at least 8 trees. Okay, so maximum number of rows is 80 divided by 8. 50 plus 30 is 80. We have to have at least 8 trees in each row, so we'll need a 10 rows. Okay. And other options are 10 apple trees plus 6 peach trees in each row. That would give me a 5 rows. Okay, 25 apple trees plus 15 peach trees in each row. That will give me a 2 rows. Okay, or 50 apple trees and 30 peach tree in one row. That will give me 1 row. Okay, let's continue from here. Okay, here's an example we were talking about in the daily use examples. We're going to carpet 12 feet by 12 feet room. Okay, here's the problem stated again. Linda wishes to carpet 12 feet by 12 feet room. She can find only 9 feet wide roll of carpet and she buys 16 feet of the roll. Okay, let's continue. So she cuts the carpet in two parts in okay and then carpets the room with those two parts. Can you figure out how she does it? Let's see what we do. Let's continue from here. Hence 9 feet side is 3 feet short and 3 is a HCF of 9 and 12. Okay, 16 feet side is 4 feet too long and 4 is HCF of 12 and 16. So we need to use those two facts here. We'll use two hints here to guide us in devising a plan of action. So let us continue from here. We know we will use the 3 and 4 here, which are HCFs. Carpet example. So we have 16 feet long and 9 feet wide carpet. Okay, a room is 12 feet by 12 feet. Let's continue here. So carpet is 4 feet too long. We'll start a cut from 4 feet into the length, and carpet is 3 feet too short, so we'll cut out a 3 feet line here, okay, along this 3 feet line, and which is 4 feet from the edge here. Okay, let's continue. This is my first cut. Okay, this is the part of my first cut. Okay, let's continue here. Then we'll continue again by 4 feet, which is HCF of 4, 12 and 16, and so this is will cut parallel to the length. Okay, and then we'll next section of the cut will get a 3 feet deep cut here, which is on the side of width because width is 3 feet too short. Okay, let's continue here. Then we do another cut here, which is 4 feet long. Okay, starting from this cut here. Okay, then we finish up with a 3 feet cut along parallel to the width of the roll. Okay, let's continue. Then in this line I just drew out for way identification that where cuts are. Now can you see how we are going to carpet the room with the two pieces here? One piece on the right and top of these staircase lines, and another piece is to the left. Okay. 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 First thing is that from here, Linda can take this piece and spread out flush against the one corner of the room, and take out this piece, spread it out and flush against the other corner such that this side and this side are along the sides of the room. Similarly, such that this sides and this sides are along side of the room. Okay, let us continue from here. Well, let's see what we are going to do here. Okay, you could have done also cut like this. Here, we need 12 feet and 4 feet too much, so we just cut along this line here. Okay. Then we have a 4 feet wide and 9 feet deep section here. Okay. Let's continue. Then we'll take our 4 feet or 3 feet section this here, and 4 feet by 3 feet here. So we got a 3 carpets rectangles 4 by 3. Okay, so we can take these carpets here section and spread them out on the bottom here. Okay, so that also could do that, but that would get me 4 pieces, one this piece and 3 more. Okay, we were looking for 2 pieces. Okay, so we won't use this divided along this line and then make 3 rectangles more. Okay, let's continue. We are going to do this. We're going to take this part here and move it left, move it down 3 feet. Okay, take this section here, move it down 3 feet. Okay, and after that we'll move that section to the right by 4 feet. Okay, do you see what's going on here? I'll give you some time to think about and visualize what's going to happen. Okay, let us continue and see how it looks like after we carpet the room. Let's look carpet here. Now we have a 1 square room, 12 square by 12 feet by 12 feet. Okay, and here my carpet on top, the one piece, another piece is on the bottom. Okay, these lines help me identify where the cuts were. Okay, so we are 12 feet by 12 feet, and we were able to do by using two pieces of the carpet. Okay, let us continue from here. Some problems here. Find the HCF of the following problems. Okay, 72 and 112. The next is 143 and 110. Next is 15, 30 and 105. Next is 63 and 27. Okay, then is 140 and 160, 64 and 96. Okay, 57, 95 and 38. Okay, 37, 222 and 999. 81, 405 and 567. Okay, okay, then it is a 98, 294 and 490. Okay, that's 39, 143 and 142857. Okay, let us continue from here. Let's now continue with the next section here. We already discussed HCF. We discussed how to compute that using factors. Let's continue. Now in this section we will compute HCF, highest common factor, and we will use divisions to do that. In the next section we will do a compute HCF using by addition and by subtraction. Okay, let's continue. Compute HCF. The example I am using is from the book Figuring. Find the HCF of 4781 and 6147. Let us continue from here. This is the method we learned at school. Okay, so this is the method they teach at school. At least they did that in my school. Okay, let us see what's going on. A method is divide the larger number by smaller number. So this is the larger number here, 6147, and 4781 is smaller number. So we'll divide that this larger number here by this smaller number. Okay, let's continue and divide divisor of previous number by remainder from above. So first we'll divide 6147 by 4781. Next we will divide 4781 by the remainder of the first division. Okay, let's see. And then what we do? Repeat above two steps until remainder is 0. So we'll continue to do that. Okay, we'll first divide a larger number by a smaller number, then divide the divisor of previous number by remainder from above, from this one here. Okay, and then repeat above two steps until remainder is 0. Okay, last divisor is the required HCF. So we keep dividing the remainder, keep reminding the divisors by the remainder until remainder is 0. Okay, from book Figuring, HCF is of 4781 and 6147. So we would divide 6147 is larger and 4781 is smaller. So we would divide 6147 by 4781. Let's continue from here. So here's my division setup. 6147 is my dividend and 4781 is my divisor. Let's continue. So if I divide 6147 by 4781, okay, I get a 1 remainder 1366. Okay, if I subtract 4781 from here, remainder is 1366. Now we'll divide the previous divisor, which is 4781, by this remainder 1366. Let's see the setup for next step. Here is 1 remainder 1366. I divide 6147, the larger of the number, by 4781 by the smaller of the number. I get 1, remainder is 1366. For the next step, this remainder 1366 is the divisor, and this number which was divisor before is now a dividend. Okay, let's continue on next step. So next step, this is my divisor, which is remainder from first division, and this is my dividend, which was a divisor before. So the dividend remainders become the divisor in the next step, and the divisors become the dividend on the next step. So the remainder becomes the divisor for the next step, and divisor become dividend for the next step. Let's continue from here. So now we're going to divide 4781 by 1366. Okay, and I got a 3, remainder 683. Okay. Okay, now if you need time to think about and work it out, please do. Okay, let's continue from here. Now divide previous divisor, which is 1366, by this new remainder, which is 683. So let's look at the setup for next step. Okay. So we have 3, remainder 683. So now this remainder here from this division 4781 by 1366, this remainder is going to be divisor for the next step, and this divisor in the previous step will become a dividend in this next division. Let's continue from here. So this is the setup. 683 remainder from this division here 4781 by 1366 is my next divisor, and the divisor here 1366 is my next dividend on the next step. Okay, let us continue. And if I divide 1366 by 683, I got 2, remainder 0. So remainder is 0. So the last divisor is my HCF. HCF is 683. Let us continue. I got 2, remainder 0, and HCF is 6, remainder is 0. Last divisor is HCF, which is 683. Let's look at another example here. HCF of these three numbers 192, 204 and 272. We will continue to use the same method, which was method using divisions. Let's continue here. And this example is also from the book of figuring. Find HCF of 192, 204 and 272. Okay, let's continue from here. We keep dividing all three digits by common, which is usually prime common factors. Product of all these common factors is HCF. So we'll divide by common factor. A factor which is common to all three of the numbers. All of the numbers in here, in this example, there are three numbers. Okay. Okay. We keep dividing all three numbers by common factors which are usually prime. Okay. Let's continue. Okay. So here is example 192, 204, 272. Okay. Do you see any common factor here? Okay. So here's the setup for division. Okay. And you see that this is number even, this is even number, first number is even, second number is even, and third number is even. That means it's divisible by 2. 2 is a factor of 192, 2 is a factor of 204, and 2 is a factor of 272, and 2 is a common factor, common of for all of these three numbers. Okay, let's find out. Continue. So if we divide 192 by 2, I get 96. Now we'll divide 204 by 2. So we already know how doubling and halving works. So this is a halving here. So 204 divided by 2 is 102, and 272 divided by 2 is 136. Okay, let's continue and let's see. Is this number even now? Is divisible by 2? It is. Is this divisible by 2? It is. Is this divisible by 2? It is. 136, 102 and 96. They have another common factor of 2. So which is 2 is a prime number. So this is my second prime number. Okay. So 2, we go next time again we would divide by 2. Okay, let's continue. Okay. All right. So when you divide 96 by 2, what do you get? 48. If I divide 102 by 2, what do we get? I got 51. Then do repeat the same for 136. What do you have? Okay, I get 68. So, okay, now let's look at here. This is an even number, and so is the 68 is even and 48 is even, so they are divisible by 2. But the middle number 51 is odd, so it's not divisible by 2. Okay, so is there a common factor here? Let's discuss that. Okay, there are no more common factors. Okay, okay, let's find out. 48 is equal to 2 times 2 times 2 times 3. Okay, this is 48 is 16 times 3. Okay, okay, okay. And 51 is 3 times 17. 5 plus 1 is 6. 6. That means this number is divisible by 3, and 3 times 17. So in 48 and 51, the common factor is 3. Now let's look at 68 here. 68 is 2 times 2 times 17 is a 17 times 4, 68. Okay. 2 is a common factor in 48 and 68. Another 2 is a common factor here. Okay, but 2 is not a factor of 3 times 17. Okay. Alright. So but 3 is a factor in the first two numbers, 48 and 51, and it's not here. So there is no common factor here. There is no factor which is a factor of 48, 51, and 68. Okay. So these are the two common factors we had, and our HCF is product of these two factors with 2 times 2. So HCF is 2 times 2 and is 4. So HCF of 192, 204, 272, 192, 204, 272 is 2 times 2, 2 times 2, and which is 4. Okay, let us continue from here. Okay, let's continue here for the with the next section. Okay. We have done HCF. We have computed the using factors. We have computed the using divisions. Okay. Let's go. Now we would compute HCF using by addition and by subtraction. Okay. So we will compute HCF using the sutra by addition and by subtraction. Okay. In factors, we will using proportionalities, and using division, we were using division by remainders. That's why we keep using remainders in the next divisions as a divisor. Let's continue. So we'll do HCF by addition and by subtraction, and this section is from the book Discover Vedic Math by Ken Williams. Okay. And in this section we will use sutras by alternate elimination and retention. It's by alternate elimination and retention, and also by addition and by subtraction and proportionality. Okay. By the way, anytime we multiply or divide, we are using this sutra, proportionality sutra. When a number has a factor, it's proportional to that factor. So we'll do the factors that we were using proportionality. Okay, let's continue here. Determining factors is determining proportionalities. Okay, so if 3 is a factor of 6, this number 6 is proportional to 3. Okay, let's continue. Okay, now it's the next, we continue with the same idea, same topic by addition and by subtraction. This is continued one. Okay, and this is the example from same book. I mentioned this Discover Vedic Math. Find HCF of 493 and 697. Okay, let's continue here. So by addition, we add the two numbers together, 697 plus 493. Okay? And its total is 1190. Okay. So if you need time to think about and add them up, please do. Okay, so we add 697 and 493. I got 1190. Okay, let's continue from here. And that's 10 times 119. Okay, I know 10 is not a factor of neither 493 or 697. It's 119 is a candidate for being a factor of 697 or 493. We have not established this one if 119 is a factor, but we say this is a candidate and we would use that further. Let's continue. And if you need a prime factors, that's a 2 times 5 times 119. Okay, let's continue. Do another now, and one this is further it is 2 times 5, 119 is has a factor of 7 and 17, 7 times 17. So we get all the prime factors here. Now we are going to do a by subtraction. We're going to do a subtract this number. We will subtract 493 from 697. Okay, let's continue here, and I got 204. Okay, 697 minus 493 is 204. 204 is 2 times 2 times 51. Okay, 2 is a factor of 204, and that makes it 2 times 102, and 102 also has a factor of 2, that makes it 2 times 51. Now you look at 51, 5 plus 1 is a 6, and that means 51 is divisible by 3. Okay, let's continue. Like 2 times 2 times 3 and times 17. Okay, okay, so that means that okay, 119 has a factor 2 times 5 times 7 plus times 17, and also this 204 also a factor 2 times 2 times 3 times 7. If you look carefully here, 17 is common to both. 17 is common to both, and 2 is common to both. 2 is common to both. But neither 493 is even number nor 697 is an even number. So 2 cannot be a factor, common factor, but 17 is. So 17 is a common factor of 493 and also 697. Okay. The book has a proof that why this addition and by subtraction works, and after we got this number by addition and by subtraction, if I use these numbers instead of the original numbers, I still get the same HCF. Okay, let's continue. So HCF is 17. HCF of 493 and 697 is 17, and we got that through by addition and by subtraction. Okay, and here we added them up together like 697 plus 493. Okay, why did we do that? We were trying to get a 0 in the end. Okay, we were trying to get a multiple of 10, and that way we can eliminate the 0 here because 10 is not a factor of 493 and 697, but I held on to it for a while, okay, so that you can see what is going on. Okay, so HCF of 493 and 697 is 17. Okay, let us continue from here. Continue, and let's try to revisit this number in this example here, 21 HCF of 2184 and 1638. Okay, let's see if we can do it another way. Okay, find HCF of 2184 and 1638. This example is from the book Discover Vedic Math by Ken Williams. Okay, so this time we tried divide and conquer. In the previous slide we tried by alternate addition and by subtraction. Actually we used a proportional add. Okay, so numbers are 2 is a common factor, so it's 2 times 1092 and 2 times 1819. Okay, we'll try to uh, divide and conquer. Okay, so we just divide that into two factors. First number is 2 times 1092 and second number is 2 times 819. Okay, and now let's go divide again. We got an I know that it's a 1092 is divisible by 4, so it's 2 times 2 times 2, and after that 273. Okay, and this one is 2, and this number is divisible by 3. 2 times 3 times 273. So we have 273 here on this second number, and we have 273 in the first number. Okay, and we also have a 2 here. We also have a 2 here. 3 is not there. So HCF is 273 times 2, which is 546. HCF is 546. Okay, let's continue. And if you care to, you can find prime factors. Okay, let's continue. I mean, you can continue finding factors, which are so we, first number is 2 times 2 times 2 times 3 times 91. Okay, and second number is 2 times 3 times 91. Okay, let's continue. And 91 is 7 times 13, so then 91 is 7 times 13. So we have a 2, 3, 7, and 13. 2, 3, 7, and 13. These are the common factors here. Okay, let's continue. And it's a 2 times 3 times 7 times 13. It's a 2 times 21 times 13 is 2 times 273, and it is equal to 546. Okay, let us continue. Exercises. And I got these exercises also from the book Discovery Vedic Math. Okay, let's continue. 6314 and 5236 are two numbers, and you find HCF. The next example is exercises 5916 and 5304. Next is 2457 and 1593, and some more. Okay. Let's look at now references here. Okay. So this is a common reference we have. It's Teacher Manual, Volume 1, which is Elementary Level by Ken Williams, and you can find this book at vedicmaths.org, and PDF form is free. Okay? So you can find that Vedic Math Teacher Manual, Elementary Level, and this is by Ken Williams, and you can find it on vedicmaths.org. And if you look for PDF form, that is free. Vedic Math by Bharati Krishna Tirthaji, that's the primary reference on Vedic Math. If there's anything related to Vedic Math, it probably is covered in Tirthaji's book, okay? Or at least referred it then, okay? Okay, let's continue and discover Vedic Math by Ken Williams. That's the most complete, authoritative, and consistent notations, and the book is organized by sutras. This by addition and by subtraction method is in this section. For sutra by alternate addition and by alternate elimination and retention. Okay, so Vedic Maths for School in 3 volume by James T. Glover. Mr. Glover used these books in high school. Easy to read, very complete, and contains significant geometry which I have not covered. Okay, so I got part of that. Those my HCF from here. Okay, and some examples, and also a whole section here by addition and by subtraction from this book here. Okay? And then figuring by the method by HCF by division I got from this book figuring. We also referred some videos, and these videos are the video on fractions. We use that to see have we used HCF before. Okay, and then there we use mentioned by divisibilities when we were trying to divide by 11. Okay, and then multiplication by completion. This is we discussed multiplication by sequence of 9. This video contains that. Okay, okay, and this video also contains that multiplication by sequence of 9s. This video also contains the multiplication by sequence of 9s. When we say 142857 was 143 times 999, and those how we do multiply two numbers by sequence of 9s is contained in these two videos. Okay, let's continue, and that's all for the references.